Our third exercise is called currency conversion. And it says create a program that converts an amount in US dollars to another currency. Okay, so executive decision, we're going to use Canadian dollars. Prompt the user to enter an amount in US dollars and the exchange rate of the other currency. So here, it's actually not telling us what exchange rate to use. It's asking us to expect the user to give us that information. So actually I didn't notice that until just now when I was reading this through. So this is one of the things that the program is going to take in a sense as its input. And then, based on that, it's going to calculate and display the amount in the other currency. So in this case, you enter, let's say, $5 and you give the exchange rate, and then it's going to tell you that is equal to this number of Canadian dollars. And as before, we're going to have to work around this prompt the user business, but we have a pretty easy way to do that. Now, I guess one thing I'm curious about here is, hey, I'm wondering what the exchange rate is. Is my new colleague, does it know that? What is the current exchange rate from US dollars, that'd be USD, to Canadian dollars, or CAD? Okay, yeah. I think ChatGPT's lawyers know better than to let it tell me anything about that. Okay, so I'll just copy the exercise here, and then I'm going to go over on my other screen, and I'm going to just quickly look up that exchange rate. There we go. So, okay, according to Google, it's currently, if you want to check my math, it is currently August 20th, 2023 at 10:20 a.m. And as of 10:20 a.m. on August 20th, 2023, Google is telling me, it dates this to 9:51 a.m. on August 20th. Google is telling me on my other screen that the exchange rate is 1.36. So I'm going to write this as of 9:51 a.m. on August 20th. $1 is equal to 1.36 CAD. Okay, so that's the exchange rate we're going to use. Unfortunately, ChatGPT can't help me with that, but fair enough, I guess that's not its area of expertise. As before, I will modify the exercise to say start with, because we don't yet know how to get user input, although it would be an interesting thing to try out if you're interested. Start with an amount in US dollars and the exchange rate of the other currency, and then perform the conversion. All right, so we'll try that out. I'm going to say double US amount, and I don't know, we'll start with $10. So the reason why that's helpful, I think, is that if I start with $10, I guess I should get $13.60 if I use this exchange rate. So I'll do exchange rate. I'm going to name my variables carefully here. So this is the kind of program I might want to come back and modify later. And so if I use variables that are really self-explanatory, I don't need to provide too many comments to explain what I'm doing. So USD to CAD equals 1.36. So $1 is equal to 1.36 Canadian dollars. All right, and now I can print out the CAD amount, so double Canadian amount. And that's just going to equal US amount times exchange rate. All right, and then I can print that out in some format. So here, of course, I've decided, it actually went unspoken, but I decided to use double, and that's because we're talking about dollars and cents. And naturally, at least at this level, it feels like that's right, because obviously, if I'm talking about an amount of currency, I would say something like, $1.36 or $6.10, and that I would write that as 6.10. So, if I write this, we interpret this currency measurement actually as a real number, and it's specifically a real number with 2 decimal places. Now, I'm going to say something else about this in a minute, but in the meantime, I think for the sake of the exercise, not if you get a co-op at a bank, but for the sake of this exercise, it makes sense to use double. And it also makes sense to always print things out to 2 decimal places. So let's see. I'm just going to print, just so I don't have a number beginning my line, currency conversion. I'm going to print out my amount of US dollars, so that would be %.2f, because I really like using 2 decimal places because it feels wrong to have currencies displayed to a different number of decimal places. So that number of dollars, US dollars, equals this number of Canadian dollars with an exchange rate of, and then I'll print the exchange rate so anybody looking at this understands where I got the number. Okay, so I'll print these things out. So that's the US amount first. I'm going to break this printf statement over multiple lines just to make it more easy, to fit on the screen. There's the US amount, the Canadian amount, and the exchange rate. All right, so we'll run this program, and then I will have to test it, as well as having to say a few things. Okay, so let's see. Why is it complaining here? In my printf statement, it says too many arguments for format. And I'm noticing, actually, it's not necessarily obvious if you stare at this. It's one of those things that you have to really look for. But what this warning is saying, and we already know in this course that sometimes the text of the warning doesn't help you at all, but at least it's saying, look at line number 23. There's something wrong with line 23. So what the warning is saying, though, I happen to already know what this means. What this is saying is you have given too many numbers to sub in and not enough places to substitute them. And you might have heard me doing a double take, because I'm pretty sure I did give. There's one number, there's another, and there's the third. So why is it complaining? And if you stare at it carefully, you might already see the typo that I made. Actually, there's one substitution, %.2f, and this isn't a substitution. It's just $.2f. There's no percent sign. There's the second substitution. So as far as the compiler is concerned, there are two substitutions in this line, and then this weird looking thing, which, is deceiving. To a human eye, this might look sort of like a substitution, but it isn't. And if you get a warning like this, you might just have to sort of stare at it, like just go through character by character and try and figure out what's going on, because it might not be obvious. When there are all these symbols involved, it's not always easy to figure that out. That's one of these debugging skills you have to build over time. And because your brain tries to short circuit things, it tries to see patterns and jump to conclusions. And therefore, it's easy to stare right at this and not realize that you're missing a percent sign. But I'm going to add my percent sign there. So there it is. I'm going to try compiling again. And if the warning goes away, that's a sign that I did actually find it and fix it. Okay, so that's a good sign. So I'll try running it. $10 US equals 1360 Canadian with an exchange rate of 1.36. Okay, that's a good sign, but I'm not done testing yet. And before I start testing, I want to make one other observation, which is this is not something we care about in the first week of a programming course, but it turns out in life, in the life of a programmer, there is one thing you ought to know about if we're doing calculations involving currency, which is you should never, ever, ever, ever use a floating point type for real currency calculations. Never, under any circumstances, is that going to be a good idea if you are dealing with the reconciliation of currencies. So if you are writing code for a bank, you do not use double or float. If you are writing code for investments, you do not use double. Even if you're writing a mortgage calculator out there in the real world, you would not use double or float. When you're working with currencies, you should do something else. Although it may not yet be clear what that is. We're not going to talk about that too much in this course. Just remember, so in case anybody watching this video is thinking I am suggesting that we use floating point data for currencies, no, I am not. Although it's a fun exercise by a certain definition of fun, and for the sake of the first week of class, float or double works just fine. But just a weird aside, it turns out that float and double have a certain weakness. And we already know a little bit about the weaknesses of float and double. They don't give us perfect precision. They can result in rounding errors. And rounding errors are, I don't know, the kind of thing that upset people a bit if the rounding is applied to their money. And that's one reason we shouldn't use floating point data for currency data. We'll see later in the course a few other options for what we might do there. We won't worry about them for this exercise. So for this exercise, this is just for our own edification, we are going to use float and double. Okay, so for my testing, what should I test? As before, I should make sure that if I try and convert $0, that obviously 0 US dollars should always equal 0 Canadian dollars. Okay, and it does. I should verify that if I use a quantity that is not $10, so let's do, I don't know, $6.10, that it comes out looking right. This is something, I obviously can't do this in my head, so what you might want to do over on the side, what I'm going to do over on my other computer is I'm now going to verify if I do 6.10 times 1.36, that indeed it comes out to be, well, actually it comes out to be the actual result there, so 6.10 times 1.36, if you try this on a calculator, or you try it on your other computer, it will actually come out to be 8.296. And that gets rounded to 8.3. And you can see here why currency calculations are sort of a thing, because although we can tolerate rounding or we can tolerate having only a certain number of significant digits with scientific data, with currencies, it's a bit of a sensitive topic. But okay, so I guess it does come out to be 8.3. If you're doing currency conversions, if you're running a currency conversion business, you're going to have to give people a change in dollars and cents. And so you're going to have to do some kind of rounding to deal with situations like that. You can't give out fractional cents. And to be honest, cents are worth so little that maybe it doesn't make much of a difference. But there's another example of why currency stuff is sort of weird. But don't blame me. I am not the one that suggested this exercise. Okay, but in any event, 8.3 does seem reasonable for 2 decimal places for this conversion. Let's try at least one more. I don't know, we'll do 187.17. So I'll try this out. And notice how my tests have involved a mixture of numbers like 10, but also values that contain fractions like 0.17, like this example. It comes out to be 254.55. I can just go try that out on my other computer over here, 187.17. Yeah, it comes out to be this number here. So 254.5512. And of course, I don't know what to do about fractions of a cent, so it comes out to be 254.55. That looks good. I'm not going to worry about things like negative values because that's a little bit weird. I mean, I guess you could use that to convert debts or something, but I don't see the need to do that here. I should also, just as one quick test, even though we sort of assume this exchange rate will, it may change over time, but we were sort of assuming that for today, for the exercise, it's always going to be this. I should verify that if I change the exchange rate, I see that change reflected in my results. So let's say that we end up with this. I don't know if we want the Canadian dollar to drop this low, but suppose that the exchange rate ends up being 2.0. We'll just quickly verify that does makes that in the formula that does work out. So yeah, it does look like, so 187 times 2 is 374. So this does look like if I change the exchange rate, the program does adapt to that. It does react properly. Okay, so I'll change that back because I don't want to look too much at that awful exchange rate. Okay, there it is. And that's our third exercise for this week. And we'll try another set of exercises next week to see if my new colleague ChatGPT can help us out with our next topic, which is going to be loops.